All righty. Well, let's get going. We'll probably have a few trickle in here as we get going. But today for Lunch and Learn with Dojo 5, we've got our guest is Sandeep Kamath. Or Kamath? I should have asked you how to pronounce that. How do you Kamath. Okay. Almost like chemist. All right. Sandeep Kamath. And he's the founder of SwaraLink Technologies. SwaraLink develops some cutting edge products and services focused on Bluetooth and BLE systems, embedded software, and IoT. He describes himself as a deeply technical hardware and embedded software engineer, 15 years experience professionally and responsibilities across engineering management, biz dev, and biz ops management. In the past, he's worked at TI, NextWave, and Micronis. So there's a lot of value, and really excited to hear what you have to say today. So thanks so much, Sandeep.
Yeah, thank you, Joe, and thanks for having me on here, and thank you and the Dojo 5 team. It's really great to be here. I've actually enjoyed a few of the webinars you've given, so I don't know how I found out about it, stumbled upon it, and figured that I could contribute as well. So I really appreciate being here. My name's Sandeep Kamath. I operate my business, SwaraLink Technologies. And our topic today is best practices for Bluetooth Low Energy product design. So a little bit about myself. I've been working with Bluetooth Low Energy technology now for just over 11 years. So kind of since the infancy of the standard. I was previously the applications engineering manager at Texas Instruments, leading the Bluetooth Low Energy software applications team, and then later managed the R&D team. So I've kind of dealt with every possible issue you can imagine when it comes to Bluetooth Low Energy. In 2017, I left TI and started my own business, SwaraLink Technologies. What we do is we offer a range of services centered around Bluetooth technology, primarily software development, mainly embedded development, but we also will dabble in app development or even cloud software. We'll help with architecture and debugging services. We can do hardware design, and we'll even take on full product development projects. And we offer consulting services as well. So if you're doing anything with Bluetooth, we're here for you and can help with really any aspect of your design. So a little bit about this presentation. Last year, I wrote a document called the Bluetooth Low Energy Developers Checklist. This is a PDF document that it's free to download. I'll share a link at the end of the webinar. But essentially, it's a checklist of best practices for product design for Bluetooth Low Energy. And some of the contents here might not apply to every single application because in reality, every product is different, every application is different. So, I always want to make sure that you shouldn't take every single thing as gospel and that everything needs to be followed very strictly. But hopefully from this, most of these apply to most Bluetooth Low Energy products. And even if it doesn't directly apply, hopefully you can still find value in what we talk about here. Hopefully this content as well, if you're familiar with Bluetooth Low Energy and have worked with the standard, there might be some things you pick up here that are new. And if you're new to Bluetooth Low Energy and still learning about it or just kind of interested in Bluetooth Low Energy, I think you can learn a lot about the technology from what we present here. So let's start going. So I'm not presenting, am I? One second. All right. So to start with, let's look at what are some common issues with Bluetooth Low Energy products that are out there. These are issues that I've seen repeatedly over the years, and if you've bought a Bluetooth product, there's a very good chance that you've seen these issues as well. So the first issue that I see is reliability. Have you ever had a Bluetooth product that when you're trying to pair it, the pairing seems to fail, or maybe a product which seems to disconnect randomly? I mean, it's sad, but there's many products out there that are just not reliable. Another issue I see is power consumption. The whole point of Bluetooth Low Energy is low power consumption. Even, low energy is in the name. But with that said, there's a lot of products that I see that are made that just don't live up to their, what they claim for the battery life. So power is a big one for, if you're making a Bluetooth Low Energy product, you're probably making it to be a low power product. So you want it to be low power. Security, this one is, I don't think I need to talk too much about this. There's a story in the news every week about some kind of hack that happens, and more of those stories are involving IoT devices, connected devices that are insecure. If you're making a Bluetooth Low Energy product, you want it to be secure. You don't want to be the company that is on the news because of, you didn't follow good security practices. And the last one I've listed here is user experience. And in some ways, user experience sort of is the culmination of all of these other things. If you have an unreliable product or a product where the battery dies in 3 days, you're not going to give a good user experience to your user. And, this is where people end up with returns on Amazon or bad reviews, or just, people getting a bad, your product getting a bad reputation. But in addition to that, just, having things like having your app function in a reactive way when it's communicating with your Bluetooth product. These are things that are common problems that I see and can be done much better with a lot of products. So why do these issues occur? There's a lot of reasons, and I've given a few reasons here. So complexity of the specification, that's one thing. The Bluetooth 5.2 specification is over 3,200 pages long. No one has read that spec from beginning to end. So there's a lot to take in there, and it's very easy to miss some details or to make mistakes when we're making a product. Another issue is limited feature support in stacks. So when you're designing a Bluetooth product, you're probably using a chipset from a vendor, and the vendor is going to give you their stack, or it's going to be an open source stack. And these stacks that they provide don't always support every feature. They might not support the latest Bluetooth security features. They might not support the latest privacy features. They might have things which limit your throughput. So, when you're even designing your product, you want to be careful of the chips that you're selecting, what features are supported, what features do you need, what features do not need. These are all very important when making a decision for your design. Another issue I see is confusing marketing of features. And this issue, I would say that the Bluetooth Special Interest Group, which is the organization that drives the Bluetooth standard, I would say they might be the most guilty of this of everyone. Because if you look at Bluetooth marketing documents, as well as marketing from chipset vendors, you'll see that they offer 2 megabits per second high throughput mode, long range mode. They offer this feature and this feature and this feature. What they don't tell you is you can't use all those features at once. If you're using high throughput mode, you can't use long range mode. Those are 2 different modes, and when you're using long range mode, you're going to get lower throughput. This is just some of the confusion that's out there, and it's marketing that can be very misleading. So you want to be a little bit careful when you're looking at these things. The last reason here I've listed is limited examples in SDKs. So what happens here is you get a development kit from a chipset vendor, and you start working on your Bluetooth project, and you take one of the examples in their SDK. Well, you know that this stack supports the privacy feature, and it supports the LE secure connections feature, and you know that they claim that they can give you a certain amount of throughput. But the problem is this example might not actually be using all these features. So if you're basing your product design on an existing example, you got to make sure that these examples actually are taking advantage of all the features that you need and are taking advantage of all the features and things that I'm going to discuss in this presentation. So let's look in depth at some of these things. I read that my BLE product should last for years on a single coin cell battery. So how come it dies after just 2 weeks? I've heard this one or some variation of this one on many occasions. A common reason for this, I would say, falls in that limited examples and SDKs, where people are just kind of following the basic examples and not really understanding some of the more details of how connections work in Bluetooth Low Energy. So, you know, the biggest reason that this happens is because people are not using the appropriate connection parameters or advertising parameters. So if you're not too familiar with Bluetooth Low Energy, the way that the protocol works, the kind of the general theory behind it is the devices transmit packets very infrequently and sleep the majority of the time. So you can have, if you think of a product such as like a Fitbit, for example, which, you know, once per second it's sending your heart rate and your activity monitor and, you know, other data. But that's sending that data once per second, and it's a very small amount of data. We're talking maybe 10 bytes of data per second, 20 bytes of data per second. So if you were to look at how the Fitbit is working, the MCU is sleeping literally probably 99% of the time. And, you know, maybe even longer than that, maybe 99.9% of the time. And for that 0.1% of the time, it wakes up, does a little bit of processing. The radio will wake up, transmit its packet, and then when it's done, it maybe does a little bit of post-processing, and it goes back to sleep. And then it sleeps for, you know, 999 milliseconds, and then it wakes up again and repeats. And the connection parameters and the advertising parameters are the parameters that determine how often you're waking up, how often you're sleeping. So essentially, your connection parameters will impact your power consumption, your throughput, and your latency. So if you just use the default connection parameters, they might not match what your actual application needs are. So, you know, when we look at different types of products, a bad product will just use the default parameters. And, you know, to give you an example, when an iPhone connects to a Bluetooth Low Energy product, the iPhone assigns it a connection interval of 30 milliseconds. So if you have a product where you only need to send data once every 5 seconds, or once every 2 seconds, or once per second, if you're waking up once every 30 milliseconds to send data, you're essentially waking up and sending what's called empty packets. So you're burning a lot of power unnecessarily. So bad products do this. They don't actually set their connection parameters what's needed. They just take what's given to them. Good products will set parameters to optimal values. So, you know, Bluetooth Low Energy has procedures for a peripheral device to request an optimal set of parameters from the central device, which in this case would be the phone. But even better products will dynamically update their connection parameters. So what I mean here is, let's say you have an application where you typically are sending, you know, a few bytes of data per second, but maybe there's times you need to go into a different mode where you're going to transfer large amounts of data and you want to transfer it quickly. Maybe there's times where you want to do something like an over-the-air firmware update, or you have a file transfer that's going to happen. Well, Bluetooth enables you to dynamically update these parameters. So what you can do is, right before the firmware update is going to happen, you send a request to switch to a faster set of parameters. You wait for the phone to acknowledge the request and change the parameters. Then you switch into, say, a 30 millisecond interval. You transfer your file and you do it quickly, which gives, provides a good user experience. So they're not sitting and waiting 10 minutes for a firmware update to complete. The firmware update can complete maybe in 20 seconds. When the firmware update's complete, or when the file is transferred, then you switch back to a slower interval to save power. So this is the best way that you can design a product to optimize your system for your needs. So this slide here, I just call this the connection parameters cheat sheet. And this cheat sheet is also included in that Bluetooth Low Energy developers checklist document that I I'll share the link for that at the end of this presentation. So if you'd like a copy of this, you can get it. As I understand, I think this presentation will, I'm not sure if the presentation will be recorded as well. But we don't need to get into all the details here, but the short story here is if you look at the top here, the connection interval, if you use a fast connection interval, you're going to have higher power consumption, but you're going to get better throughput and better latency. So lower latency meaning when you want to transmit a packet, it will be received at the peer device faster. If you use a slower interval, you're going to get better power consumption, but you're going to get worse data throughput and worse latency. On the bottom here, I've listed another chart for slave latency value. So slave latency, if you're not familiar, it's a feature in the Bluetooth Low Energy specification that allows for a device to, basically allows a slave device or a peripheral device to skip connection events when it doesn't have any data to send. So this is a super useful feature that not a lot of products use. So by using slave latency, essentially, if you look at this chart here, if you use a high slave latency value, you can reduce the power consumption of your peripheral device without having any impact. And I shouldn't really, there's a little bit of impact, but it's a very small impact to your throughput. So you can still get high throughput from in the slave to master direction. You can still get high throughput, but in the master to slave direction, sorry, you can get low latency in the slave to master direction, but for the master to slave direction, you're going to have delays. So you need to kind of account for that. If you use no slave latency, you're going to have higher power consumption, but you preserve your master to slave data latency. So it's a very useful feature. If you're not familiar and you're designing a product, you should consider using it if you have a product where the main purpose of the product is you're sending data from your peripheral to your central device, or, for example, from your sensor to your phone. Isn't the throughput in BLE 2 megabits per second? I'm not getting anything close to that. So there's a few reasons why this misconception happens. So the next tip here is you should optimize your data throughput, but in order to do that, you need to understand how throughput in BLE works a little bit. So the first thing to realize is 2 megabits per second is the maximum PHY data rate. So that means at the physical layer, the radio is physically transmitting 2 megabits per second while it's transmitting. But if you think back to what we talked about with connection intervals and connection parameters, if the radio or if the system is sleeping 99% of the time, then you're not constantly transmitting at 2 megabits per second. So, you know, there's other things to account for as well. There's the fact that Bluetooth Low Energy, you're not transmitting and receiving at the same time. So if it's a bidirectional connection, that time needs to be split between transmitting and receiving. There's your connection parameters. There's also protocol overhead. So 2 megabits per second is kind of the raw data transfer rate, but in reality, there's a lot of extra bits and bytes that are sent that are needed for the Bluetooth Low Energy protocol to function. So at the application layer, your throughput is going to be significantly less, and it's going to vary by a lot of factors. The first factor is just the connection interval and the parameters and slave latency, like those types of things that we talked about. But I'm going to give you a couple other tips here that will help you make significant improvements to your throughput. So the first one is to understand how procedures work in Bluetooth Low Energy. These are sometimes, these are called ATT or GATT, Generic Attribute Protocol, or Generic Attribute Profile procedures. And if you use the write request or indication procedure, what happens is you're going to have your data sent on one connection event, and then you got to wait for the response in the next connection event. Then your data is sent, then your response is sent. So effectively, you're sending one packet every other connection event. Now, instead of using write requests or indications, there's there's some other procedures. One is called the write without response, which is also known as the write command packet, or the notification procedure. And when you're using these procedures, data is sent on every connection event, and you can queue up packets back to back. So in this picture here, you'll see there's 4 data packets that are sent on connection event 1, then 4 more data packets on a connection event 2, and so on. So assuming that you're getting 4 packets per event, you've effectively got, you've made your throughput 8 times faster than from the previous image. And different systems can handle different numbers of connection events different numbers of packets per connection event. And it also depends on the size of the packets and things like that. Just to answer a common question that gets asked, so if the throughput is not 2 megabits per second, I've given a lot of explanations of how to improve it, but what is the actual max application throughput you can get? In most cases, when people ask that, they're thinking about communication between a Bluetooth peripheral and a mobile phone. If your phone is an iOS device, then your maximum theoretical throughput, if you're optimizing everything correctly, will be around 50 to 60 kilobits per second. With Android phones, it varies because different phones behave differently. But the max that I've seen or heard about is around 100 kilobits per second. But again, this only works if you're optimizing your connection parameters, optimizing the way that you send these packets, and do some other things right. So the next tip I'll give you for optimizing throughput is to use a large PDU length and a large ATT MTU value. So a little bit of history here. Bluetooth 4.0 was the first spec which introduced Bluetooth Low Energy. And in Bluetooth 4.0 and 4.1, the maximum packet length was 27 bytes. And effectively, most types of packets, you only get 20 useful bytes of application layer payload within that 27 bytes. Bluetooth 4.2, they increased it to 251 bytes, which is really 244 bytes of application layer payload per packet. But that's a significant increase. So, if you're using if you're select a chipset that supports Bluetooth 4.2 and supports the extended packet length feature, then you can send these large packets. But even if you're supporting the feature, you need to make sure that you set you need to set these values, which usually are not the default values, 251 bytes for your link layer max PDU length, and 247 bytes for your ATT MTU size. If you set these values, and if your peer device that you're talking to supports these values, you'll get a much larger throughput than you would otherwise. Quick side note here is that there's no guarantee that a peer device will use these values. So if you're designing your system to use a large PDU length, you need to make sure that your system is able to handle whatever your peer device gives you. So the way that works is you might request 251 bytes of data length, but your peer device, like say your phone, might say, I can only give you 150 bytes per packet. So you basically, the system will use whatever the lesser of the two devices is able to support. So your application can't be designed around a fixed number of bytes. It needs to be designed in a way where it can handle whatever the peer device is going to give it. Is Bluetooth secure? This is a tough question. So this is an interesting question because I get asked this from anyone and everyone. Certainly in technical settings when I'm meeting with clients or people are designing Bluetooth products, this is a big question. But interestingly, this is a question that comes up a lot in casual settings when I'm meeting people in non-professional settings, people who don't have technical jobs, or they're not even, they may or may be technically minded people, but when I tell them, hey, I work on Bluetooth, that's what I do for a living. This is one of the most common questions that comes up. They say, like, hey, like, I'm talking on my Bluetooth headset, is that actually encrypted? Or when I'm typing with my Bluetooth keyboard, can someone be listening, watching my keystrokes? Well, the short answer to this question is actually pretty easy. And the answer is yes. Bluetooth is actually very secure. The standard has, there's a lot of smart people who have developed the standard, a lot of people with very strong security backgrounds, and the standard has been developed to be very secure. But the slightly longer answer to this question is yes, Bluetooth is secure, but it's only secure if you implement it properly. And this kind of ties back in with what I'd said about complexity of the standard. If you're using most Bluetooth stacks will support all the Bluetooth features, but there's a complexity of the standard, and then you need to make sure that you're actually using the features correctly. So if you understand how security works in Bluetooth, and if you use the features correctly, then no system is 100% secure, and bugs can always be found, but you can design a pretty secure product with Bluetooth if you do things correctly. And this is a complex topic, so how do you do things correctly? Well, that could be a whole presentation in itself, but I'm going to give you a couple of tips here that can make a big difference. So the first tip is to use the LE Secure Connections feature. So with Bluetooth Low Energy, there are two options for pairing. So the first option is LE Legacy Pairing, which was the original method for pairing in BLE, and this was the only option that was available in Bluetooth 4.0 and 4.1. The problem here is that LE Legacy Pairing has a known security vulnerability during the pairing process. So to explain that a little bit further, what that means is when you're doing the initial pairing, the first time that you connect the device to your phone, if someone is listening in, sometimes this is called the passive eavesdropper. So you have, a lot of times in security, we talk about Alice and Bob. So in this picture, you have Alice, who's the message sender, and she's sending a message to Bob, who's the message recipient. And then you have this person here, Eve. So Eve is the eavesdropper. Eve is someone who's sitting outside of the room with some, specialized equipment. It doesn't even necessarily need to be that specialized equipment. You can do this with, $20 worth of hardware and the right software. But Eve is listening in with a sniffer and monitoring every single packet that's being sent back and forth between Alice and Bob. And Eve, if she listens to all the packets and knows the algorithms which are used for Bluetooth, which are known and public and standardized algorithms, then Eve can actually break the encryption and from that point forward decrypt every single packet that's sent back and forth between Alice and Bob. Now the good news is in Bluetooth 4.2, the LE Secure Connections feature was introduced. So this was, it was introduced in 4.2. There were some improvements in the Bluetooth 5.x standards. And LE Secure Connections is based on the elliptic curve Diffie-Hellman key exchange algorithm. If you're not familiar, elliptic curve Diffie-Hellman key exchange is one of the most important algorithms that's used in cryptography. And essentially what it does is it enables this exact same scenario with Alice and Bob, where Eve, the eavesdropper, can listen to every single packet that's sent between Alice and Bob, but still not be able to decrypt the messages. So there's really no reason not to use LE Secure Connections. It's supported by pretty much any new Bluetooth Low Energy device supports it. All the phones support it. All of them will try to use LE Secure Connections by default because it's clearly a better way to go. The only reason legacy pairing is really supported is, it's in the name. It's for legacy reasons. If you do have an older device that doesn't support it, okay, using legacy pairing is better than nothing, but there's really no reason not to use secure connections. The next tip I'll give here is that you should prevent unauthorized connections. And this is one that very few devices actually do anything about this. So there's a funny thing that happens here, that many BLE devices that are out there are just open for connections. And what that means is I can take my phone and download one of many available apps that sometimes are called like BLE Explorer apps. A very popular one is Light Blue, but there's many others like NRF Connect. And essentially these are just kind of general purpose Bluetooth Low Energy applications, which let you discover devices, connect to devices, perform reads, writes, do just some basic general functionality. And if you go into any public space and open up one of these apps, you can see all the advertising Bluetooth Low Energy devices in the area. And you can connect to them, and oftentimes they'll just let you connect to them. And then you can start reading data and writing data. And it doesn't necessarily mean that it's easy to do something malicious, but it's not a very good design practice to enable this. And there's a few reasons why. So what can a malicious device do? So the very first and simplest thing that it can do that's kind of bad for your product is it can create a denial of service attack. So this could be as simple as I've created a Bluetooth Low Energy product, and when the user of the product, I want them to be able to connect to the product at any time. So at any time, they should be able to take out their phone, open up the app that's designed to work with the product, and connect to it. Well, if they're in a public space and someone else happens to be in the area who opens up Light Blue and sees their product and connects to it at the same time, well, then the user themselves will not be able to connect to their product. And this is one of those things which I would say falls under bad user experience. So if you've ever had a Bluetooth Low Energy product or any Bluetooth product where you open up the app and it doesn't seem to connect, it's possible that the reason is actually that there's a denial of service happening, that some other rogue device has actually just connected and hogged the connection. So even though to the user, it just, the user might just think, oh, my product's broken because I'm not able to connect to it. When in reality, the product's not broken, it just wasn't designed to protect against a denial of service attack. So this is something that it sort of falls under security, but it also falls under user experience and reliability. So that's just the simplest malicious thing that can happen. Another thing that can happen is if an unauthorized device connects, they can just burn a lot of power on the device, because if they're connecting and reading and writing data, you're burning the battery unnecessarily. So that's not good for the product. And then lastly, another bad thing that can happen is there can be an increased attack surface. So what that means is now once the user has connected to your device, they can start reading and writing data. So that gives them the possibility of potentially reading data that should be secured. If your product is something like a medical device, then they can do they might be able to do something dangerous that impacts the user. Even if you've designed your application to be have some kind of application layer password or things like that, you've basically enabled an attacker to get one step closer to doing something malicious. So, in security, this is often called the attack surface. You want to minimize your attack surface. And by allowing unauthorized connections, you've just given a huge attack surface to the attacker. So how do we prevent unauthorized connections? There's different strategies to go about this, but there's one feature that's used or that's supported in the Bluetooth Low Energy standard that very few products actually use, and that feature is called the whitelist. What whitelist filtering does is Whitelisting allows a BLE device to restrict connections to only authorized peer devices. So essentially what happens is if an unauthorized device requests a connection from your product will just ignore that request. It won't even respond. It's not like it will respond and say, sorry, you're not authorized. It will just completely ignore it and pretend like nothing happened. So the unauthorized device is just gonna, basically their connection is just gonna fail. And hopefully the attacker, they try a couple times, they see that they can't connect, then they just give up and move on to the next device they want to attack. The whitelist works very well if you're making a product that has a one-to-one pairing. So, where there's one user who's typically only going to use it with one phone. Essentially what you do is during the pairing process, you use secure connections to, get strong encryption. And then once the pairing process is complete, your peripheral device whitelists the phone so that no one else's phone or no other BLE device can connect to it. Then if the user is, let's say the user gets a new phone. Well, if they get a new phone, they probably need to go through the pairing process again. So oftentimes, that involves pressing and holding a button down or something like that. And when they go into the pairing process, then you can stop whitelist filtering temporarily so that a new phone can connect to it. Another issue which is it's kind of a little bit of a different class of a security issue, but it's more of a privacy issue. So when you're designing a product, I really highly encourage you to think about privacy. In general, the concept of privacy is one that I think more and more people are familiar with from a technical standpoint, just from all the things that have been in the news of the last few years. And again, like data leaks that have happened, people's private data getting leaked. That's that's a serious issue in the broader technical world that we live in. But there's also privacy issues that come with that are involved with Bluetooth that not a lot of people are thinking about. And Apple and Google have done a very good job of with their phones and with their devices using the Bluetooth privacy feature, but very, very few peripheral products are using the Bluetooth privacy feature. So why do you need this? What is the threat here? Well, in a lot of public spaces, there's Bluetooth-enabled nodes that are now deployed everywhere. So we're talking airports, shopping centers, even on city streetlights. In fact, here in San Diego, where I live, a couple years ago, San Diego partnered with, I believe it's with GE, and many of the streetlights in the city have become smart nodes, which have cameras, which is a little scary, but also are equipped with all types of wireless technologies, including Bluetooth. We don't know what that Bluetooth is doing, but it would be very easy for them to just turn that Bluetooth on and start scanning, which basically means listening for Bluetooth advertisers and just logging the address of every Bluetooth device that it finds, and it can log that and track it. And now you can imagine if you have a Bluetooth device which is advertising, then if you had a network of these nodes, which could be in public spaces or in retail spaces, well, if the Bluetooth device address gets linked to you as a user, well, now you're effectively being tracked. Your location is being tracked by Bluetooth. And I haven't heard of anything very bad happening with this yet, but I almost think that it's a matter of time before some story in the news comes out about something bad that's happened, whether it's a company that gets caught kind of using this as a means to kind of track people's location, or a government entity, or something else. I really think it's a matter of time before this becomes a bigger story than it is. But the thing is, the Bluetooth, the people who work on Bluetooth standards committees have thought about this, and the Bluetooth standard has a feature called the privacy feature. In Bluetooth 4.0, this feature was not very well, it wasn't well defined and was very confusing. And since Bluetooth 4.0, with pretty much every release of the spec, there have been improvements to how this feature works. And I think because it was a very confusing feature early on, it got a little bit of a bad rap, so people didn't use it. But it's come a long ways, and it actually works very well now and is supported by most stack vendors and most chip vendors. So this is a feature that I encourage all of my clients and anyone who's making a Bluetooth product, I would encourage you to use this feature. And the way that it works is your Bluetooth device will advertise using a random periodically changing address rather than a fixed address. And that means that if there's scanning devices out there, they're not always going to be scanning the same address. Typically, it's about most systems, the address changes every 15 minutes, but there's no reason it can't be even more frequently than that. And the idea here is that only a trusted peer device can decode the random address, can decode the fixed address from the random address. And they do that using something called an IRK, an identity resolving key. So essentially, it makes it so that when you pair with a device, say your phone and your peripheral device pair, the two devices exchange IRKs since they trust each other, and then those two devices can know about each other even when their addresses change. But the greater public that's listening will not have this IRK, so they won't be able to decode it. Another piece of advice I give, which is not so much just a security feature, but it's also just a good practice for a product, and that is to future-proof your product by supporting firmware updates. So if we look at security vulnerabilities in products, there's several different types of vulnerabilities that exist. So the first one is at the application layer itself. So your Bluetooth product that you make, if you haven't implemented your application perfectly, or if there's bugs in your application, which if you write software, you know that every software can and will have bugs, and that happens. It's a natural part of software development. But if there's security bugs in your application layer, that can expose potentially data that should be encrypted, or allow some bad functionality, or allow some malicious to do something. So you want to be able to support updates in order to fix those issues. But even if, let's say you're the greatest embedded developer in the world, and you've written an application that is 100% bug-free and has no security vulnerabilities, the problem here is most cases, you're not writing your own Bluetooth stack, but you're using a stack that's coming from the device manufacturer, or using an open source stack. It's coming from somewhere else. And Bluetooth stacks are software, just like your application is, and it's written by real engineers who have bugs in their software. So there's Bluetooth stack manufacturers are constantly coming out with updates to their stacks, as well as open source stacks. And sometimes there are security vulnerabilities in their stacks. So you want to make sure that you can handle updates which will be able to patch or resolve any issues that were found in the Bluetooth stack. Then the last type of security vulnerability is actually in the Bluetooth spec itself. And this has happened. Last year, there was one that was found even in LE Secure Connection. So I know I said Bluetooth is secure, but even there are some bugs. I mean, they're not necessarily easy exploits, but researchers have found bugs in the Bluetooth specification. And what happens then is newer versions of spec come out which address the issues. So For example, last year there was some bugs that were found in the Bluetooth standard. Then Bluetooth 5.2 was released. Well, first an errata was released, which was released quickly and enabled chip vendors to update their stacks with fixes immediately. But then in the Bluetooth 5.2 standard, this errata was rolled into the core specification. So every Bluetooth 5.2 qualified device has to have a fix for the issue. So the way this works, if you support over-the-air firmware updates, is you can have your firmware image pushed from the cloud to the user's mobile application, and then when the user opens up the app, imagine something like a pop-up saying, "There's a new firmware update available for your product. User, would you like to perform an update right now?" User hits yes. If you've optimized for throughput, hopefully that over-the-air firmware update will take less than 30 seconds. If your application's small, it should be much faster than that. And you push your update to the product, and then the product reboots itself and starts running with the new firmware. There's a few best practices of how to do over-the-air firmware updates. One of them is to use an authenticating bootloader and sign your firmware images. So this protects against a malicious person creating their own firmware and pushing it to your product. Another best practice is to encrypt your firmware image. So this protects someone from taking your firmware binary and decompiling it or reverse engineering it. So if you follow these practices, you can have a good future-proof device that's protected from, have the ability to patch any issues that are found. My device won't pair with my phone, or the connection seems unreliable. So we've talked a little bit about why this might happen, and there really can be a lot of reasons why this can happen. So I have a couple of tips here that are kind of general tips that can help with some of these issues. So the first one is ensure interoperability. So all Bluetooth devices follow the Bluetooth core specification, but the exact behavior and feature support can vary. So if like many people, if you're making a product that talks to a iOS or an Android phone, it's best to follow. Apple has a document called the Accessory Design Guidelines, and this is it's publicly available. If you Google Apple Accessory Design Guidelines, you'll find it. And they have a whole section on Bluetooth and a whole section on Bluetooth Low Energy, and it gives all types of things that you must do in order to be interoperable with the iOS, and things that you should do which will improve your interoperability with iOS, like what kind of connection parameters it supports, what GATT services you need to include, what features are supported, what features are not supported, things like that. Google, unfortunately, has not done nearly as good a job about documenting this as Apple has. So with Android, you need to be a little bit careful. Android has definitely, Bluetooth Low Energy support in Android has definitely gotten better over the last few years than it was, say, pre-2015. It was pretty inconsistent and there were a lot of issues with it, but now it's gotten much better. So one good best practice is when you're creating your mobile application is only support a certain, don't support phones from 2012, require your users to support a certain version of Android. It's up to you which version you want to choose, but a certain version of Android or a certain version of the API to ensure that they're using a newer version of Android on a newer, relatively new phone, and will get reliable behavior. And then lastly, it's not mentioned here, but test against devices. Test against a few different Android devices, because just because it works with one doesn't mean it will work with another, especially if you're doing a lot of complex features. If you're doing basic things like simple connections, simple reads and writes, then there's less to worry about. But if you're doing things like multiple connections and trying to push the limits on throughput and latency and doing things like that, then you'll want to do more testing. And the last tip I have here is use appropriate UUIDs. So what are UUIDs? They stand for Universally Unique Identifiers. And in Bluetooth, UUIDs are used for every GAT service and GAT characteristic. If you're reusing UUIDs, then what happens is you might have issues where someone else's mobile application, like say another product's application, is trying to connect with yours because you're using the same UUID as them. Or you might also have issues where, well, the other issue here is actually if you're not using a UUID properly, you might actually be violating the Bluetooth core spec. And there's many products out there that do this. You know, I don't think there's any Bluetooth police that will come after you, but you're technically violating the spec and it could lead to problems. So the proper way to use UUIDs is use what's called a version 4 or random 128-bit UUID. This is a simple, safe, and free way to create a UUID. You don't have to register it with any kind of centralized database. And if you do it properly, then the odds of a collision between you know, your UUID being reused somewhere else, it's statistically basically impossible. It's because there's so many bits of entropy used here. If you're using a proper random number generator, your UUID will never be used again by anyone else. One thing you should consider is the Bluetooth SIG has a program that allows you to purchase 16-bit UUIDs. I believe it's $2,500 per UUID. So it's not necessarily something that everyone needs, but there's some value to this. By doing this, it lets you to reduce the size of the advertising or scan response data, which therefore will provide a reduction in your overall power consumption. And also it can reduce service and characteristic discovery times, which means when a connection happens, the time between from the moment the connection happens until you can start sending application layer data can be reduced, just because you're now sending smaller data packets because you're using smaller UUIDs. So that pretty much wraps up my presentation. As I mentioned, everything that was covered in here is also covered in the BLE developers checklist. You can download it at www.blechecklist.com. That connection parameters cheat sheet is included in there. And the checklist includes a little bit more detail than what I was able to cover here. So I'd encourage you to check it out. It's free. If you have any, if you're interested in learning more about SwaraLink technologies and our services, please visit us at www.swaralink.com. Again, thank you to Dojo5 and thank you to Joe for having me here. And I think we'll now open it up for questions.
Yep, exactly. Thanks so much, Sandeep. And that was a great presentation. Good value during it, and also some great information to follow up with. That's awesome. So yeah, if anyone has any questions, feel free to toss them in either the Q&A or the chat. Zoom gives us, you know, one option and then an additional redundant option. So two ways to do it. But otherwise, thanks so much. Are you able to see? You should be able to see the questions, right, Sandeep? We just had one come in.
You know what? My Zoom is, here we go. All right.
There, under Q&A. Says, how about Bluetooth mesh?
Hey, Susan, thanks for joining. Good to hear from you. I see a couple friends of mine listed here. Susan, Chuck, glad you guys could join. Great question. So Bluetooth mesh is relatively new. It's even though it's been standardized for a few years, it's still going through a lot of growing pains, and it's very complex. I would say that a lot of what I cover here does not apply to Bluetooth Mesh, just because Bluetooth Mesh, as it's specified today, only uses advertising and scanning. It's not actually using Bluetooth connections. So let me, there are a few things that are covered here, which is like, especially understanding your advertising parameters. That's going to have a big impact on your mesh throughputs and latencies, as well as your power consumption. But besides that, I'm kind of flipping through my slides here. One second. Besides that, I'm not sure if much else that I covered really applies to mesh. The only other thing I'd say with mesh is that most Bluetooth mesh systems, you want to be able to support connections as well as support doing mesh. So if you're designing a system which supports Bluetooth mesh, you still probably are going to support connections for things such as commissioning devices onto the mesh network and firmware updates, things like that. So for those cases, I think all of the things that I presented here still apply. But when you're being used in sort of the mesh use case, your advertising parameters and scan parameters are what's going to have the biggest impact on things such as latency, power consumption, et cetera.
What have you done? One of the questions for me, I guess, that I can toss in. Have you done anything with the new direction finding stuff with BLE, angle of attack, angle of departure? I'm just curious what you see as kind of the future of BLE and how that'll be used.
So I think AOA, AOD, and direction finding is a super useful feature which has a ton of potential. I think it's a $1 billion problem, billions of dollars of value in this technology. The problem is, so what Bluetooth 5.1 gave us with AOA AOD was introduced in Bluetooth 5.1, but the truth is Bluetooth 5.1 didn't actually introduce direction finding. All it introduced was the ability to send what's called a continuous tone packet attached to your Bluetooth packets, which enables, essentially enables this angle of arrival, angle of departure, this type of algorithm to be done. But the Bluetooth spec did not define the algorithm for actually calculating the direction. So what's happened is every chipset vendor has realized that, oh, this is actually a really, really hard problem to solve. Just because I have what's called the I and Q data that comes from the continuous tone doesn't mean that I can very easily calculate the angle of arrival, angle of departure. There is one company based out of Finland called Kuuppa, Q-U-U-P-P-A. I think I'm saying it correctly. And Kuuppa, it's a bunch of ex-Nokia guys who essentially were the ones who, it was Nokia that was pushing this standard for years. I mean, I remember back in 2009, before Bluetooth 4.0 was even adopted, that Nokia was working on defining this standard, and it didn't get adopted until I think 2018 or so. So very recently, and Kuuppa is the only company that I know of that seems to have a pretty good implementation of it. All the chipset vendors have that I've seen have said that they would give something, and it's sort of been a, we'll have something in 3 months, we'll have something in 3 months, and now it's been 2 years and something's coming in 3 months. So I think it's a very complicated problem. It's, it takes some very hardcore RF engineering. It's not a simple, hey, I have 2 numbers and I do some trigonometry and calculate the angle. There's RF is very complex. And so, to answer the question, I think at some point it should become more broadly available, and I'm sure it will become easier, and I'm sure the chip vendors will we'll have better support for it at some point. I just don't know when that is. All right, will LE Audio put BR EDR out of business or impact it? Great question. I think that LE Audio over a long period of time will put BR EDR out of business. But when I say a long period of time, we're not talking, I don't mean next year that's going to happen. I don't even mean 3 or 4 years from now. I think it will have an impact 3 or 4 years from now. And maybe 10 years from now, we'll stop seeing BR EDR headphones and things being introduced. Maybe sooner than that. But yeah, LE Audio is, I think I could have probably said this even as long as 5, 8 years ago, that eventually Bluetooth Low Energy is going to support audio, and eventually that's going to overtake classic Bluetooth. Because I mean, Bluetooth BR EDR or classic Bluetooth is basically technology from early 2000s. So Bluetooth Low Energy has evolved significantly since then. Of course, semiconductor technology and RF technology has evolved significantly since then. So LE Audio consumes less power than BR EDR and supports more features. It's still in its infancy, so I think it will take a little bit of time before it catches on. And of course, phones will need to still support, even a phone 10 years from now will probably need to support a Bluetooth headset that came out in 2020, which is classic Bluetooth. So I don't think phones will stop supporting BR EDR, but I think over time you'll start to see, initially you might see dual mode headsets or headphones or speakers, which are supporting both. And then eventually, once most phones support LE Audio, then you'll start to see low energy headsets and things like that. But it will take some time.
All right. Well, awesome. Thanks so much, then, Sandeep. We got to close it off there. But as always, thanks everyone for attending. Great information. Next week, we're talking about embed ops and DevOps processes for firmware. So join us for that if that's of interest to you. And keep in touch with both Dojo 5 and SwaraLink for lots of various firmware and product needs. Thanks so much.
Thank you.